Welcome to EDU World Space.
So here we have the trajectory of a bird, or the velocity vector, given by this equation. And what we need to do is we need to find the acceleration position vectors. So in order to find the position vector, all we're going to do is integrate the velocity vector. So if we integrate in the i-hat direction first, we get alpha t minus beta over 3 t cubed. Now normally we would, since we're integrating, we have to add r naught, or in this case it'd just be x naught, but we know it starts at the origin, so x naught and y naught are just going to be 0, so we can get rid of those. And this is going to be in the i-hat direction. And now for the j-hat direction, it's going to be gamma over 2 t squared, j-hat direction. Now for the acceleration vector, all we have to do is take the derivative of the velocity vector. So acceleration vector is going to be equal to negative 2 beta t in the i-hat direction plus gamma in the j-hat direction. Now next we need to find the altitude, which is going to be the y-coordinate given by the j-hat and the position vector right here. We need to find it when the bird flies over x equals 0 after time equals t. So if we take the x component of the position vector, which is in the i-hat direction, alpha t minus beta over 3 t cubed, we want to find where that equals 0. So if we factor out a t, alpha minus beta over 3 t squared equals 0. We see that one of the values for t is 0, but we don't want that because we want after t equals 0. So all we do is alpha minus beta over 3 t squared is equal to 0. We solve for t and we get t is equal to plus or minus the square root of 3 alpha over beta. But since t can't be negative because it starts at 0, we're just going to use the positive value. And plugging the numbers in for alpha and beta it gave us, we have t is equal to 2.12 seconds. Now we're going to take that and we're going to plug it into the position vector in the y direction, so the j-hat component. So all we do is gamma over 2 t squared is equal to y. Plugging it in, we have gamma is equal to 4. Gamma is equal to 4 over 2 times 2.12 squared. And we get, after rounding, that's going to be 9.0 meters.